Moog, the problem solver. Building superior chassis parts begins with an engineering philosophy that never stops asking, how can we make it better? That's the philosophy behind Moog chassis parts from Federal Mogul. Parts engineered not only to perform, but to solve problems.
Thanks for viewing this training module about Moog suspension and steering components. We'll begin by explaining why a customer may need chassis repairs and the various components that make up the system so that you'll feel more comfortable discussing Moog chassis with your customers. We'll also cover what type of symptoms the vehicle may have if the chassis parts have worn, and then cover the reason that Moog chassis parts are the technician's choice and how to explain their features and benefits. Why would a customer need to buy suspension and steering parts? These parts move every time the vehicle rounds a turn or hits a bump, so wear can occur. This wear can create looseness, which causes handling or ride quality issues and affects tire life. In severe cases, vehicle safety could be affected. Most worn parts are noticed during a wheel alignment, vehicle inspection, or during a complaint of poor handling, ride quality, or excessive tire wear. The vehicle may have a loose feel in the steering or a noise when turning or hitting bumps. Proper inspection and replacement of worn parts is a good investment in the life of the tires and ensures good handling, vehicle ride, and safety. Most suspension and steering parts wear occurs in the front of the vehicle due to additional weight and more excessive movement of the components. Parts wear can occur gradually due to age, lack of lubrication, or inferior internal components. Many OE components and aftermarket offerings are designed without grease fittings and have internal components which most likely will not last the life of the vehicle. Some commonly replaced components include ball joints, control arms and bushings, and sway bar links. All components should be inspected periodically to head off more serious problems. Most suspensions use triangular-shaped control arms to attach the wheel to the frame or unibody. The spring is placed between the control arm and frame or on the strut to hold up the vehicle. The control arms move up and down like hinges when the vehicle hits bumps, which reduces road shock in the passenger compartment. The blue components in this photo are the control arms. To test the ball joints for looseness, they must be unloaded, meaning the load must be removed from them. The method varies with type of suspension used, but involves lifting the vehicle and testing for axial, which is up and down looseness, and radial, side-to-side looseness. Some ball joints have a specification for the amount of looseness, which normally relates to safety. Looseness that allows tire movement can influence handling and tire life. This is an upper control arm on a typical rear-wheel drive vehicle. The control arm bushings pivot and allow the arm to move when the vehicle hits bumps. At the other end of the control arm is the ball joint, which attaches to the steering knuckle, where the wheel is mounted. There are 4 ball joints on this application, 2 uppers and 2 lowers. They allow the vehicle to turn, and their angles change when hitting bumps, which makes them subject to wear. At the attachment point to the vehicle frame, which is painted orange here, is a number of shims of various thickness. This is where the alignment is adjusted for caster and camber. Removing shims makes the top of the tire go outboard, increasing camber, and adding them makes it go inboard, which decreases camber. Most front-wheel drive cars use McPherson strut suspension, which was designed in the late 1940s. The suspension system is well suited for lightweight vehicles, but can be easily damaged if subjected to rough terrain or overloading. Typical problems include strut leakage, sway bar link noise, upper strut mount looseness, and noise and ball joint issues. The OE ball joints are often designed with a plastic bearing with no grease fitting. Over time, the boot can develop a tear, allowing the grease to escape and water to take its place. Because there's no grease fitting, the problem just gets worse from there. As seen here, this joint completely separated. The water can rust the bearing stud, making it abrasive like a rotary file. You can see the rusty surface of the separated ball joint stud. As the vehicle is steered back and forth during normal operation, the stud eats away at the plastic bearing material, and the part becomes loose. In extreme cases such as this one, the driver experiences loss of steering control. In less extreme cases, this looseness affects handling and can create noise and reduce tire life. Later designs incorporate aluminum components which are often more fragile. The ball joint is often made into the arm, requiring entire control arm replacement when the ball joint fails. Rear-wheel drive vehicles may have either a solid axle with coil or leaf springs that have only bushings, springs, and shock absorbers that wear and fail, but the more common front-wheel drive vehicles will use McPherson struts on the rear too, with all the same wear and failure items as a front suspension, such as ball joints, bushings, struts, strut mounts, and often tie rod ends. The steering system on most modern vehicles consists of a steering column leading from the steering wheel to the rack and pinion assembly. This assembly converts the rotating motion of the steering wheel to linear motion to steer the wheels in the intended direction. Some older vehicles, light trucks, larger vans, and SUVs use a conventional steering linkage and a steering gear box to convert the rotating motion to move the linkage from side to side and steer the vehicle. This system can handle heavier loads, but there are many moving parts subject to wear, such as idler arms, tie rods, and center links. The adjusting sleeve is where the toe in the steering wheel center is adjusted during alignment. This is a typical parallelogram steering and suspension system in operation with all its components painted different colors for easier viewing. As the steering wheel is turned, you can watch how all the steering linkage components work in concert. All the joints and components must be in good working order to produce good handling and protect the life of the tires. Looseness of any of the sockets may cause erratic handling, wandering, and dramatically reduce tire life. In severe cases, a joint could separate and cause an accident. Today's tires are very expensive, and periodic steering and suspension inspection and repair is the key to catching a problem before it damages them. Most technicians use the dry park test to check for side-to-side looseness and steering linkage. With the vehicle setting on its tires, the steering wheel is rocked slightly back and forth while someone else inspects all the components for looseness. Another test shops perform is to compress each linkage socket with hand force and look for excessive looseness that could cause toe change. Remember, looseness of any of the sockets may cause erratic handling, wandering, and dramatically reduce tire life. Why Moog? Commercial customers already know Moog and usually ask for it by name. This is because they have used the brand for many years and have found it to solve the problems on the vehicle once and for all. Moog strives to re-engineer the parts they make to be better than the one they replace in terms of longer life, and often adds a grease fitting to maintain the life of the part. In addition, some parts are designed to be easier to install and in some cases provide alignment capability that wasn't provided by the car maker. Moog's problem-solving approach is one of the reasons Moog is the market leader with the technician and with the do-it-yourselfers. As these charts show, Moog is the overwhelming choice of the automotive industry with over 50% of the total U.S. chassis parts brand share and growing. Since the early 1900s, Moog has been the inspiration of the automotive aftermarket. From their proactive leading role and problem-solving products to their superior quality of parts manufacturing, they've always been in the forefront of the industry. Moog engineers work to make parts last as long as possible with the finest materials, such as a full ball stud for superior strength and long life, a full 360-degree range of movement, consistent articulation, and grease grooves for lubrication. One-piece forged housings for unequal durability and strength, and an all-metal Gusher bearing that replaces plastic with inherent strength, reduced friction, and high wear resistance. This may cost more up front, but in the long run is the wisest investment. Some of Moog's competition follow the OE design with plastic bearings and no grease fitting and claim this to be the best. If the OE design is the best, why is the car in for chassis repairs? Most Moog manufactured parts have a pressed-in cover plate for consistent internal preloading and a grease fitting to allow the part to be maintained. A superior boot, which uses a one-way check valve, keeps out contamination from water and road grime. Moog tie rod ends use a sealed boot to further protect from contamination. Some of Moog competitors manufacture their parts without a grease fitting. Parts without a grease fitting should be compared to an engine without a drain plug. No one would expect the engine to last the life of the vehicle with the same oil that the factory installed. Proper maintenance is the key to a long-lasting part. The Moog metal gusher bearing is a file-hard, porous metal bearing which is superior material for supporting loads and tolerating abuse, while allowing lubricant to penetrate the bearing surface, resulting in increased strength and longer service life. A grease coating resides between the bearing and the stud, similar to how a crankshaft floats on a film of oil between the bearings of an engine. This is the key to Moog's longer life designs. When you grease a Moog part, grease permeates the gusher bearing material, providing a slippery surface between the stud and the bearing. This demonstration shows a sample of the porous gusher bearing material that's been soaked in oil to demonstrate how grease flows through the gusher bearing when the part is in service. One end of the bearing is blocked and air is forced into the bearing. You can see how the air bubbles flow through the porous yet file-hard surface. Moog's Research and Development Campus in St. Louis, Missouri tests their parts against the competition and the OE design to make sure that the parts will perform as intended before they can be sold. Special sensors are attached to the parts and the vehicle is driven aggressively to capture the magnitude and impact angle of the load. Moog even won an engineering award for the method used to gather data from the vehicle. Then fixtures with hydraulic rams are used to precisely simulate this load in the lab, and parts are tested to the point of failure to assure Moog chassis parts exceed our competition. Some parts are also subjected to extreme heat and cold, as well as salt water during these tests, which actually simulate the life of a vehicle in a short time by running 24 hours a day. This type of testing is unique in the aftermarket, but shows the level of commitment that Moog makes to assure a quality part for their customers. Metal is better than plastic. It's as simple as that, and Moog does it the right way, with metal. Moog uses a porous powdered metal bearing with the ability to absorb and continuously feed lubrication to the bearing surface. Other manufacturers use a polymer or plastic bearing. Unfortunately, plastic bearing surfaces prematurely deform under load and wear much faster, especially if water enters and washes out the grease on a non-greasable part. The stud can then rust and become abrasive to the plastic area, causing wear and looseness. Remember, to be the best, you have to use the best, and that's the gusher bearing. Moog ball joints are known throughout the industry as a solution to the common problem of OE ball joint failure. Many Moog problem-solving applications use a dual gusher bearing with a Belleville washer preload to keep the internal components loaded and eliminate internal movement. The grease fitting allows grease to flush through the bearing and fill and seal the boot from contamination. Moog problem-solving tie rod ends feature a swinger cup around the stud that divides up the load by providing 4 load surfaces instead of 2. A lower floating gusher bearing is preloaded by a spring that keeps internal movement in check. A sealed boot keeps road grime and water out of the bearing and keeps the grease in to feed the working surfaces. This popular problem-solving GM truck idler arm from Moog contains 2 gusher bearings on an opposing dual tapered stud and a spring preload to eliminate deflection. The reverse hourglass stud design wears in instead of wearing out, providing optimum service life. The grease fitting allows for periodic lubrication. Here we see a comparison of some sway bar lengths. The Moog problem-solving design is clearly superior for several reasons. Moog uses a stronger body structure. The OE design is either plastic or lightweight steel. The Moog design is solid metal and much stronger than either OE design. The Moog uses gusher bearings on the stud ends. Both OE designs shown here use a plastic bearing prone to failure, which is a common cause of a rattle on many small cars and minivans. Moog uses the gusher bearing, which is greasable. Moog adds wrench flats. Anyone who has ever removed the old link has had to deal with the shaft spinning. Moog uses a metal stud with wrench flats to make the part much easier to install. In addition to Moog's ability to re-engineer OE parts to make them better, Moog has developed a multitude of problem solvers over the years. These parts solve a specific issue in the field and often make the technician's job easier. If you've ever tried to lube the idler arm bracket on a late model full-size GMC or Chevrolet truck, you know that the upper grease fitting is hard to get to, especially with the splash shield in place. A Moog Problem Solver grease hose kit is now available that threads into the idler arm, and the grease fitting is relocated in a more accessible location near the sway bar frame bracket. Dodge 4x4 trucks use a track bar to control side-to-side movement between the front drive axle and the frame. It's common for the OE bar to have looseness in the stud, causing a road wander. The Moog Problem Solver design contains an improved bearing and strong preload to eliminate this problem. If more camber adjustment is needed to get within specs, Moog Problem Solver offset bushings are available to provide additional camber adjustment. Moog also offers a bushing removal and installation tool set, T40259. The rear suspension on GM W-body vehicles uses a transverse composite leaf spring that has a rubber isolator on each end. This isolator can wear and fall off, causing the spring to make contact with the metal knuckle. This typically causes a high-pitched squeak when hitting bumps. K6544 is a replacement part that takes the place of the rubber isolator. This is a quick and effective way of solving the problem without spring replacement. Earlier GMC and Chevrolet S-Series 4x4 trucks use a crossmember that supports the rear of the torsion bars. This crossmember is attached to the vehicle frame rails using rubber mounts that resemble a transmission tail shaft mount. It's common for the rubber to separate, allowing crossmember movement and noise when hitting bumps. Due to tight quarters, it's difficult to install the original design mount. A6485 is a redesigned mount that uses a bolt instead of a stud, which eases the installation, and it has much more rubber to make it last longer. If the strut rod frame collar is badly corroded or loose on the Taurus or Sable, which is a common wear problem, a Moog Problem Solver is available to repair this condition. The old collar is removed with an air chisel and the new unit takes its place. The two-piece screw-together design creates a new round hole in the frame and a clean mounting surface for new strut rod bushings. The backside nut is a square design that locks against the cradle so you don't have to hold it while you torque the front side with a 4x4 hub socket. Thread lock compound is included and the nut gets torqued to 120 foot-pounds. The washer is then installed to keep the front side bushing from being damaged by the wrench flats during chassis deflection. This provides a permanent repair for a common problem. Chrysler rack and pinion inner tie rod ends don't have any wrench flats, making the removal and installation difficult. Pipe or chain wrenches can be used for removal, but space constraints can make this difficult. A tie rod end remover tool is available from Moog, part number T40269. The remover uses set screws to bite into the tie rod housing. The improved Problem Solver design Moog inner tie rod features 1 1/8 inch wrench flats for easy installation to the rack. The tie rod also has a knurled shaft to provide a positive grip while adjusting tow. www.moogproblemsolver.com is a resource for you and your customers. In addition to a library of problem solver bulletins like the ones you just saw, there's a multitude of other helpful information at your fingertip. Did you know bulletins contain helpful information for the technician related to inspection and repair of chassis problems on today's vehicles? And online training is available for understanding suspension and steering systems and the issues that the counterperson and technician faces every day, while video clips explain specific technical issues that you'll find very informative. Moog has been a supplier to NASCAR for over 44 years, and Moog ball joints have been on every NASCAR champion's car during that time. Nearly every team in the circuit uses Moog. The same engineering designs used for NASCAR are used during the development of Moog parts for your customer's vehicle. If NASCAR crew chiefs trust Moog parts at nearly 200 miles an hour, your customers can do the same. Moog parts are not simply a copy of the OE design as many of our competitors are. It is a re-engineered design with improvements that your customers are willing to pay for if you know how to explain the Moog difference. Thanks for taking your time to view this presentation.
Moog's exclusive combination of features delivers a secure, solid steering feel and ensures consistency from part to part. NASCAR-proven designs give auto parts store professionals the best engineered, best made, and best performing chassis components available. Parts designed to install easily and to perform consistently and reliably. Moog, the problem solver, from Federal Mogul.